So now it's time to talk about a very special case as we're drawing in resonance structures. Sometimes when we draw Lewis structures, we have more bonds that we kind of know what to do with. So we need to make some decisions. I think the easiest way to explain what resonance is to actually see it in action. So let's take a look at a specific example. Let's draw the Lewis structure for the O3 molecule. That's ozone. Of course, every Lewis structure is going to start with the same calculation. S equals N minus A. The need, each oxygen, all follows the octet rule. So each oxygen will need 8. 8 plus 8 plus 8 would give us a total of 24. Available, each oxygen has 6 valence electrons. So 6 plus 6 plus 6 would get us a total available of 18 electrons. Subtract, that means that we're going to be sharing 6 electrons, which is going to equate to 3 bonds. So let's get started drawing. Let's arrange our oxygen atoms as symmetrically as possible. Pretty easy when they're all the same thing. And then, of course, let's connect everything to the center. So I've used up 2 bonds, but I've calculated that I actually require 3 bonds. So now I have a decision to make. Where do I put this third bond? Well, I could put it right here, or I could have really put it right here as well. Either decision is really acceptable. Now, what's interesting is that the molecule knows this as well, and it's actually going to resonate between these 2 different decisions. It really never decides. This double bond, again, flip-flops between these 2 locations, resonating between these 2 locations. This is a special case called resonance. So again, when you have an extra bond to place, you need to place it arbitrarily in a location as a convenience to try and finish up your Lewis structure. But in reality, that extra bond is delocalized and is flip-flopping between all of the possible locations that it could actually go. And this special condition is called resonance. So let's get back to the structure. Let's finish it out. Of course, we have 18 available electrons to draw in, and with our 3 bonds, I've only drawn in 6. I owe my drawing 12 dots. And here they are, making sure to finish out everything as an octet. Now, typically, when we have resonance, we need to draw all possible resonance structures. That means that we need to supply a Lewis structure for every possibility of where those bonds could be placed. So although this drawing is beautiful, I also need to show the double bond in the second location. So I draw a second Lewis structure. So here is the second Lewis structure. You can see it's just the mirror image. So my Lewis structure total in totality is almost finished, but I need to show that the double bond is flip-flopping between these 2 locations. So I'm going to surround both of my structures with square brackets and then show a double-headed arrow between the 2, indicating that again, I'm actually flip-flopping back and forth between these 2 potential structures.